All right, you are welcome again. Yes, we are talking about relativity, and this is our second video, right, on relativity. So, in this video, we are going to take examples, okay? In the last video, we talked about the relativity, what it is, proper time, time dilation, and all that. Please, before you continue with this, or after this, please make sure you watch our introduction to relativity. Okay, good. Now let's take a look at this question. How fast does a rocket ship have to go for its length to be contracted to 99% of its rest length? Please pay attention to this question, all right? You see, how fast does a rocket ship have to go for its length to be contracted to 99% of its rest length? Now, solution. We say that contracted length is given as proper length multiplied by square root of 1 minus v squared all over c squared. Is that true? Yes. Contracted length is given as the proper length multiplied by square root of 1 minus v squared all over c squared. Now, but here, we say we are to calculate how fast for its length to be contracted to 99% of its rest length. Hello? Good. Now, pay attention. What we are asked to calculate is the velocity, right? Good. But here, we are not given the proper length. We are not given the what? The contracted length. But let me show you something. Here we say for its length to be contracted to 99% of its rest length. 99% of its rest length. That is to say that the contracted length is 99% of proper length. Hello. That is to say that the contracted length is 99% of the proper length. Now, that is to say that length contraction, which is L, is the same as the 99% of proper length. That is going to say 99 all over 100. That is the percentage of the proper length, L naught. Is that true? Good. Now we say contracted length, which is L, is equal to 99 all over 100 of proper length, which is L naught. Now let's divide both sides by L naught. If we divide both sides by L naught, that is going to say that the contracted length all over proper length is equal to, when you say 99 all over 100, is going to give you 0.99. Is that true? Yes. Now, we say that contracted length all over proper length is equal to 0.99. Please hold it. Okay? Now, let's go back to our formula. We said that contracted length is the same as proper length multiplied by square root of 1 minus v squared all over c squared. Is that true? Yes. Now, here, let's divide both sides by proper length, which is L naught. When you divide both sides, it's going to give you contracted length all over proper length, which is L all over L naught, is equal to square root of 1 minus v squared all over c squared. Is that true? Yes. So, from the beginning, where we have just solved, we say that L all over L naught, that is contracted length all over proper length, is equal to 0.99. And then here we say that L all over L naught, contracted length all over proper length, is equal to square root of 1 minus v squared all over c squared, right? So that means we're going to say that is equal to 0.99. Hello, we have solved. I will say that L all over L naught is equal to 0.99. And here we said again that L all over L naught is equal to square root of 1 minus v squared all over c squared. So that means we're going to say that 0.99 is equal to square root of 1 minus v squared all over c squared. Is that true? Yes. Now let's go. we are looking for v. So let's square both sides. Let us square both sides. Now, squaring both sides, in our right hand side, we are going to say square root of 1 minus v squared all over c squared in bracket squared. And then in our left hand side, we have 0.99 squared. Okay, so in our right hand side, this square root will cancel squared. Is that true? Yes. So after the cancellation there, we have 0.99 squared is equal to 1 minus v squared all over c squared. Is that true? Yes. So 0.99 squared is 0.98. And then let's take 1 from the other side to the left hand side. That means we're going to have 0.99 minus 1 equal to minus v squared all over c squared. 0.98 minus 1 is equal to minus v squared all over c squared. Is that true? Yes. Now when you say 0.98 minus 1, it's going to give you minus 0.02. Minus 0.02. Is that true? Yes. Equal to minus v squared all over c squared. Now let's cross multiply. When we cross multiply, we're going to say that minus v squared is equal to minus 0.02 times c squared. Let's remove this negative. As we remove the negative, we are going to have v squared is equal to 0.02 c squared. Now we are looking for v. Then we take the square root of both sides so that this square will go. So taking the square root of both sides, we are going to have v is equal to square root of 0.02 c squared. Now, this square root of 0.02 c squared is the same as saying square root of 0.02 times square root of c squared. Now, in this c, the square root will cancel squared. That means we're going to have c. And then square root of 0.02 is going to give us 0.141. Then we have c. So v is equal to 0.141 c. You can stop here, or you can still go further. What is the value of c, or what does c mean? C means speed of light. So c is equal to 3 times 10 raised to power 8 meter per second. So it's talking about 300 million meters per second. That is the speed of light. Speed of light, it can travel 300 million meters per second. Okay, good. Now, if we are to substitute the value for this speed of light, that means we're going to say v is equal to 0.141 times 3 times 10 raised to power 8 is the same as 300 million. Okay, so that means when we multiply this, it's going to give us v is equal to 4.23 times 10 raised to power 7, or 0.423 times 10 raised to power 8. These two, they are still the same thing. Okay, so here we see how fast does a rocket ship have to go for its length to be contracted to 99% of its rest length. We're actually talking about the speed. Okay, so the speed is 4.23 times 10 raised to power 7, or we'll simply say 0.423 times 10 raised to power 8, or we can say 0.141 c. All right, yes, thank you very much for watching. Let's take more examples. All right, good.